How's it going, everybody? Today we're reading the Async Rust book, and there's a good reason why this channel is called the channel of whatever. Anyway, well, the reason why I'm doing this right now is I find myself having a hard time reading it just for the sake of learning. I guess it really is the problem of our generation, isn't it? But yeah, I find it to be really hard for me to try to read it through myself. So here we are. I think I've read this. Some language features you may be used from synchronous Rust are not yet available in async Rust. Notably, Rust does not let you declare async functions in traits. Instead, you need to use workarounds to achieve the same result, which can be more verbose. Well, that fucking sucks. Compiling and debugging. For the most part, compiler and runtime errors in async Rust work the same way as they have always done in Rust. There are a few noteworthy differences. Compilation errors. Compilation errors in async Rust conform to the same level to the same. Oh, jeez. Wow, that sucks. Well, never mind. Who's sending me messages? Oh, gee. Whenever the compiler encounters async, compilation errors in async Rust conform to the same high standards as synchronous Rust. But since async Rust often depends on more complex language features, such as lifetime and pinning, you may encounter these types of errors more frequently. Runtime errors. Whenever the compiler encounters an async function, it generates a state machine under the hood. Stack traces in async Rust typically contain details from these state machines, as well as function calls from the runtime. As such, oh fuck. Wow. Sucks. As such, interpreting stack trace can be a bit more evolved than it would be in synchronous Rust. New failure modes. A few novel failure modes are possible in async Rust. For instance, if you call a blocking function from an async context, or if you implement the future traits incorrectly, such errors can silently pass both the compiler and sometimes even unit tests. Having a firm understanding of the underlying concepts, which this book aims to give you, can help you avoid these pitfalls. Compatibility considerations. Asynchronous and synchronous codes cannot always be combined freely. For instance, you can't directly call an async function from a sync function. Sync and async codes also tend to promote different design patterns, which can make it difficult to compose codes intended for different environments. Even async codes cannot always be combined freely. Some crates depend on a specific async runtime to function. If so, it is usually specified in the crate's dependency list. These compatibility issues can limit your options. So make sure to research which async runtime and which crates you may need early. Once you have settled in with a runtime, you won't have to worry much about compatibility. Performance characteristics. The performance of async Rust depends on the implementation of the async runtime you're using. Even though the runtime that power async Rust applications are relatively new, they perform exceptionally well for most practical workloads. That said, most of the async ecosystem assumes a multi-threaded runtime. This makes it difficult to enjoy the theoretical performance benefits of single-threaded async application, namely cheaper synchronization. Interesting. Another overlooked use case is the latency-sensitive tasks, which are important for drivers. Okay. GUI applications and so on. Such tasks depend on runtime and or OS support in order to be scheduled properly. You can expect better library supports for these use cases in the future. I thought Tokyo has decent support for those things, but I don't know. Async await primer. Async await is Rust built-in tool for writing asynchronous functions that look like synchronous code. Async transforms a block of code into a state machine that implements a trait called future, such as whereas calling a blocking function in asynchronous methods would block the whole thread. Blocked futures will yield control of the thread, allowing other futures to run. Let's add some dependencies to the cargo.toml file. Wait, I thought future is built in. Anyway, to create an asynchronous function, you can use this syntax. Okay, it looks pretty familiar. The value returned by async function is a future. For anything to happen, the future needs to be run on an executor. Block on blocks the current thread until the provided future has run to completion. Other executors provide more complex behaviors, such as scheduling multiple futures on the same thread. Okay. Oh, so future does come with a async executor. It's just this one, the default one, just blocks it. Interesting. Inside async function, you can use await to wait for the completion of another type that implements the future trait, such as the output of another async function. Unlike block on, await doesn't block the current thread. Okay, wait, what? But instead it asynchronously waits for future to complete, allowing other tasks to run in the future. Allowing other tasks to run if the future is currently unable to make progress. I'm a bit confused. For example, imagine that we have 3 async functions, right? Learn song, sing song, and dance. One way to learn, sing, and dance would be to block on each of these individually, okay? However, we are not given the best performance possible this way, right? We are only ever doing one thing at once. Clearly, we have to learn the song before we can sing it, but it's possible to learn dance at the same time as singing the song. To do this, we can create two separate async functions which can be run concurrently. In this example, learning the song must happen before singing the song, but both learning and singing can happen at the same time as dancing. Okay, if we use block on learn song rather than learn song.await in learning and sing, the thread won't be able to do anything else while learn song was running. This would make it impossible to dance at the same time. By awaiting the learning song feature, we allow other tasks to take over the current thread if learn song is blocked. This makes it possible to run multiple features to completion concurrently on the same thread. Wait, I thought like, which runtime are we using? Cause they mentioned like runtime, right? Tokyo and stuff, but like, I don't see any right now, which is interesting. In this lesson, we will cover the underlying structure of how futures and asynchronous tasks are scheduled. If you are only interested in learning how to write high-level codes that uses existing future types and aren't interested in the details of how future types work, you can skip ahead the async await chapter. Okay. However, several of the topics discussed in this chapter are useful for understanding how async await code works. Understanding the runtime and performance properties of async await code and building new asynchronous primitives. If you decide to skip this section now, you may want to bookmark it to revisit in the future. Wow, in the future. It's not even funny. I don't even think they intended that to be a joke or anything, but whatever. Now, with that out of the way, let's talk about the future trait. I wonder if it's possible for me to finish the book. I mean, this book itself isn't even done yet. Haven't even like manage shared states. I think that's like, this one is like arguably, sorry, you guys probably can't see this, but like this one is like the chapter that I think I care the most about, but apparently they haven't fucking write it yet, which is unfortunate. But let's just read and see what will happen. Like, this is so far the most completed chapter. Pretty much everything else has like holes in it. I think I don't know why Rust feels so incomplete. Like I don't know. I feel like compared to I know there's like a lot of hype surrounding Rust, but I feel like Rust really feels like a incomplete language. I mean, it's still better than like the good majority of other languages out there, but like, you know, sometimes it felt incomplete to me. Especially when you compare it with something that's like more mature, like C#, right, or Java. But those languages feel very complete. Anyway, Not JavaScript. JavaScript fucking sucks. The future trait. The future trait is at the center of asynchronous programming in Rust. A future is an asynchronous computation that can be a future is an asynchronous computation that can produce a value, although that value may be empty, e.g. this. A simplified version of future traits might look something like this. Okay, we have a simple future. It has a type, output, and it has a poll. And what is this wake function? Returns itself. What? I'm so confused. I guess I just don't understand Rust. I just don't understand Rust. It has an output, it has a poll. What is poll? Okay. Poll has, oh, okay, I see. Poll has two states, it's either pending or ready. And yeah, that actually makes a lot of sense. I'm stupid. Futures can be advanced by calling the poll function, which will drive the future as far as towards completion as possible. If future I wonder what's the wake doing here. If the future completes, it returns poll ready results. If the future is not able to complete yet, it returns poll pending and arranges for a wake function to be called when future is ready to make more progress. Okay, when wake is called, the executor when wake is called, the executor driving the future will call poll again, so that the future can make more progress. I think I kind of get what it's trying to do, but at the same time, it's also kind of confusing. Like how? Because I'm assuming it's not running, right? How will you be able to call wake? Arranges the wake function to be called in when futures. So how do you arrange that? I guess my questions will be answered down the line, but without wake, the executor would have no way of knowing when a particular future would make progress, and would have to be constantly polling every future. With wake, the executor knows exactly which future are ready to be polled. For example, consider the case where we want to read from the sockets that may or may not have data available already. If there is data, we can read it in and return poll-ready data. But if no data is ready, our future is blocked and can no longer make progress. When no data is available, we must register wake to be called when data becomes ready to on a socket, which will tell the executor that our future is ready to make progress. I don't know why, but like this one sounds like weirdly political. A simple socket read future might look something like this. Okay, we have a socket, a good socket. We have a simple future. It has a socket read. It has lifetime here. I don't know what the fuck lifetime is. I probably should read the Rust book first. That is probably a good idea. How about let's do that instead of this? The Rust book. Oh, geez. Rust book is really fucking long. I guess I'll just continue reading this until I encounter something that wow, they have a new version of Rust. Experiment. Improving the Rust book. What is this? Oh, they are going to have interesting. So it's something like an interactive stuff. I understand. I want to participate. Let's do this. It's the same length, right? We have 21 chapters in total here, and what about this? We have 22 chapters. I guess there is just one more chapter for the experiment introduction. Welcome to the Rust book experiment, and thank you for your participation. First, we want to introduce you to the new mechanics of this experiment. Quizzes. The main mechanic is quizzes. Each page has a few quizzes about the page's content. We have 2 rules about quizzes for this experiment. Take quiz as soon as you get to it. Do not skip a quiz. We don't enforce those rules, but please follow them. Every quiz look like below. Try to click start. Okay, start. What is 1 plus 1? Try to click a wrong answer. What is it? A wrong answer. And we can retry the quiz. We get a correct answer. Okay. If you get a question incorrectly, you can choose either retry the quiz or see the correct answers. We encourage you to retry the quiz until you get 100%. Feel free to review the content before retrying the quiz. Note that once you see the correct answers, you cannot retry the quiz. If you spot an issue in quiz or part of the book, you can file an issue on our GitHub repository. Highlighting. Another mechanic is highlighting. You can select any part of the text, either highlight it or leave a comment to it. Once you select some text, click the pencil button and leave an optional comment. Try to highlight this text. Yes, you can use highlights to save information for yourself. And more. There are more contents. A new chapter. Okay. They have a lot of progress. Acknowledgement. Nicole Goromansky, an Amazon Web Service, provided funding for this experiment. Okay. Carl Nichols and Rust Foundation helped publicize the experiment. TRPL is the product for many people in hard working. Okay. Yep, I really appreciate that. Like, I really think for language to gain large adoption, there has to be some kinds of onboarding experience. Because, like, unless it's like a simple language, like JavaScript. No, JavaScript is not easy. It's just for some bizarre reason everyone's using it. But like, you know what I'm trying to say, right? Like, it's exceptionally hard to understand a lot of concepts when you are just getting started with programming, and especially with like, I remember like back in the early days of like, oh, this tutorial doesn't assume any prior knowledge of programming, but some will be helpful. That's dog shit, right? That's absolute dog shit, because it's hard at the beginning, and then you start to get it, but then you encounter some non-GC language such as Rust, C++. Actually, C++ is like actually easier, or at least it feels easier than Rust, because like you can just do things, and you don't have to fight, against the fucking compiler. But yeah, I'm trying to learn Rust. Forward. It wasn't always so clear, but Rust programming language is is fundamentally about empowerment. Okay, no matter what kinds of code you are writing now, Rust empowers you to reach far further, to program with confidence in wider variety of domains than you did before. Take, for example, systems level work that deals with low level details of memory management, data representation, and concurrency. Traditionally, this realm of programming is seen as arcane, accessible only to a select few who have devolved. Is that how you say it? I just can't fucking read. Devoted. Oh my god, how can I forget how to say this? How to read this? I'm just I have ADHD, okay? Take it easy on me, please. Anyway, have devoted the necessary years learning to avoid its infamous pitfalls. And even those where were we? Wait a minute. Where is it? Where are we? I just got lost. What the hell? Infamous pitfalls, and even those who practice it do so with caution, lest their codes to be open to exploits, crashes, or corruption. CrowdStrike. Rust breaks down these barriers by eliminating old pitfalls and providing a friendly, polished set of tools to help you along the way. Programmers who need to deep down to low-level control can do so with Rust without taking the caution. This is such a lie, though. This is a real lie. Because, like, if you try to write a fucking compiler in Rust, it's still not. It's not as easy as it seems. But I would say it's definitely it feels safer than C++. Because, like, a lot of times with C++, the error message doesn't even make sense. I mean, you do get more error messages with Rust, but at least they make sense. But again, I'm doing safe Rust. I'm not doing like crazy ass shit, right? But like I think just with the current ongoing Linux drama, I think it's very clear that Rust is not necessarily the system language, even though they're trying to sell it as so. Anyway, or I'm just too ignorant to make a judgment. Where are we? Oh, yeah. Without taking the cautionary risk of crashes and security holes, and without having to learn the fine points of Frico toolchain. That's true. The Rust toolchain is much better than C ones. Fuck C. C sucks. I don't know why we're still using that. Anyway, better yet, the language is designed to guide you naturally towards reliable code that is efficient in terms of speed and memory usage. Programmers who are already working with low-level codes can use Rust to raise their ambition. How do you say it? Ambition. Okay, ambition. Holy crap! I just really suck at reading. I just really suck at reading. To raise their ambition. For example, introducing parallelism in Rust is a relatively low-risk operation. The compiler will catch the classical mistakes for you, and you can tackle more aggressive optimizations in your code with the confidence that you won't accidentally introduce crashes or vulnerability. Such a lie. I mean, I got like sag faults with synchronous Rust with no multi-threading. But Rust isn't limited to low-level system programming. It's expressive and ergonomic enough to make CLI apps, web servers, and many other kinds of code quite pleasant. And many other kinds of codes quite pleasant to write. What? Like CLI application. Okay, maybe quite pleasant to write. You will find. You know what's funny? Like every time when I just watch Primeagen, right? I thought to myself, well, that's easy. I can do it. No, it's not. It's hard. It's actually kind of hard, even though he's just been a text to speech for the most of the part. It is quite hard to try to read, at least for me. So I really appreciate the fact that there's someone being a text to speech to me. You will find simple examples of both later in the book. Holy crap. Working with Rust allows you to build skills that transfer from one domain to another. You can learn Rust by writing a web app, then apply those skills to target your Raspberry Pi. This book fully embraced the potential of Rust to empower its users. It's a friendly and approachable text intended to help you level up not just your knowledge of Rust, but also your reach and confidence as a programmer in general. So dive in, get ready to learn, and welcome to the Rust community. Okay. Well, how long did we take? Holy crap, I cannot believe it took like 30 minutes just to read through that. Like, I mean that's probably a very good indicator why I'm not good at English at all. Introduction. Note: this edition of books is same as Rust language, available in the print and ebook formats from No Scratch Press. Okay, welcome to the Rust programming language, an introductory book about Rust. The Rust programming language helps you write faster, more reliable software. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict through balancing powerful technical capacity and a great developer experience. Rust gives you the option to control low-level details, such as memory usage, without all the hassles traditionally associated with such control. Who Rust is for? Okay. Who Rust is for? Rust is ideal for many people for a variety of reasons. Let's look at a few of those most important groups. Teams of developers. Rust is providing is providing to be a productive tool for collaborating among large teams of developers with varying levels of system programming knowledge. I think this is very true in a lot of ways. Like, I think Rust is just very good at like preventing yourself from shooting on your foot with memory issues. But one thing that kind of concerns me is like, but like at the same time, I guess I should provide some context to this, because like I was trying to design a programming language, and one issue that I ran into is that one issue that I ran into with Rust is that the macros are insane. Like, they're just insane. I don't like macros. I think like maybe comp time. I'm not sure if comp time is like actually I don't even know what comp time is, but like I think it would be nice to have because like the fundamental problem with macros is that it's going to generate text, and it makes it really hard for the debugging message to make any sense, right? And it also makes the formatting to be rather challenging. And I think that there has to be a better way to do it than macros. And I think like most modern programming languages don't use macros anymore. It's like, I think it's pretty much a thing that people have largely abandoned, whether it's like Zig or like newer languages, like not newer, but like Go, right? And like Dart and many more. I don't like macros. I feel like it's not hiding complexity. It's actively making the development experience worse. I think it would be nice to be able to kind of write your little language inside of your language. So like, I think it would be nice if you can somehow like integrate something like a tree sitter, and like you can write your own the compiler or interpreter should expose some API to the client, so that it's like Babel, right? You can write. Well, now that I think about it, Babel is kind of like a macro, but like you know what I'm talking about, right? Babel provides very good LSP supports, and that's something that I think is important to have. But I digress. Let's continue reading. Low-level codes is prone to a variety of subtle bugs, which is in most other languages can be caught only through extensive testing and careful code review by experienced developers. Okay. In Rust, the compiler plays a gatekeeper role by refusing to compile codes with these elusive bugs. Is that how you say it? Elusive. Okay, elusive. In Rust, the compiler plays a gatekeeper role by refusing to compile the code with these elusive bugs, including concurrency bugs. By working alongside the compiler, the team can spend their time focusing on the the team can spend their time focusing on the program's logic rather than chasing down bugs. Rust also brings contemporary developer tools to the system programming world. Cargo the included dependency manager and build tool, makes adding, compiling, and managing dependencies painless and consistent across the Rust ecosystem. The Rust formats tool ensures a consistent coding style across developers. The Rust Analyzer powers integrated development environment integration for code compilation and inline error messages, which is also incredibly slow. By using this and other tools in the Rust ecosystem, developers can be productive while writing system-level code. Students. Rust is for students and those who are interested in learning about system concepts. Using Rust, many people have learned about topics like operating system development. The community is very welcoming and happy to answer student questions. Through efforts such as this book, the Rust team wants to make system concepts more accessible to more people, especially those new to programming. I think this is very well said, right? I think this is good. Companies. Hundreds of companies, large and small, use Rust in production for a variety of tasks, including command line tools, web services, DevOps tooling, embedded devices, audio and video analysis and transcoding, cryptocurrencies, bioinformatics, search engines, Internet of Things applications, machine learning, and even major parts of Firefox web browser. Wow, what a big surprise! Wow, it's like Google saying, I can't. We are using Go in a part of our system. It's like, yeah. Open source developers. Rust is for people who want to build. It's for people who want to build the Rust language, Rust programming language, community developer tools and libraries. We'd love to have you contribute to the Rust language. People who value speed and stability. This is such a lie. Rust is not fast to write. Not in the slightest. But I would say the Rust Analyzer is still like much better than the fucking whatever shit that C++ has. That one is diabolical. That one should be illegal. I'm saying it. That one should just be illegal. People who value speed and stability. Rust is for people who crave speed and stability in the language. By speed, we mean both how quickly Rust code can run and the speed at which Rust lets you to write programs. I mean, I think there are like many good syntax sugars in Rust that makes it a much more enjoyable language to write, even compared to some simpler languages such as Java, for example. Java is really verbose to write, but I maybe it's just a problem with like familiarity, because I'm not entirely familiar with Rust, and that's why I feel like you can do like a lot more with Java in a much shorter time, because you don't have to worry about all the lifetime and drop the fucking memory and the async stuff. But I digress. The Rust compiler's checks ensure stability through features additions and refactoring. This is contrast to the brutal. How to say it? Brittle. Okay. This is contrast to the brittle legacy code in languages without these checks, which developers are often afraid to modify. By striving for zero-cost abstractions, higher-level features are that compile to lower-level codes as fast as code writes manually. What does that mean? As fast as code write manually. Rust endeavors to make safer code to be fast code as well. The Rust language hopes to support many other users as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have to accept for decades by providing safety and productivity, speed and ergonomics. Give Rust a try and see if Give Rust a try and see if its choices works for you. Okay. Who this book is for? This book assumes that you've written codes in another programming language, but doesn't make any assumptions about which one. We've tried to make material broadly accessible to those from a variety of programming language backgrounds. We don't spend a lot of time talking about what programming is and how to think about it. If you are entirely new to programming, it would be better served by reading a book that specifically provides introduction to programming. Yeah, that's for sure. How to use this book?
To be honest, I think Rust would be such a... I was thinking about like whether Rust is a good language for like newcomers, for like new programmers. Cause like if you're not teaching Rust, what else are you teaching? You're teaching you're teaching Java, right? At least that's what I was introduced. Most people were introduced, in my generation, were introduced to programming through either Python or Java or JavaScript. Right? Those are the big three. Java in particular, because like it's fucking Minecraft. Or maybe even Lua, right? Maybe if you're Gen Alpha, right, you probably got introduced to programming through Lua, which is like, I mean, there are like some programming concepts, but I feel like a lot of them are just not good. Like those languages have a very strong focus on abstractions. So like ideally you only have to deal with the design patterns and stuff, which I think gives us the slowest programs that we have seen in decades, right? Like the programs that we are using today are horribly slow compared to their predecessors. How to use this book? In general, this book assumes. Okay, I read that before. Oh, never mind. How to use this book? In general, this book assumes you are reading it in sequential from front to back. Later chapters build on the concept in earlier chapters, and the earlier chapters might not delve into details of a particular topic, but you will revisit on the topic in a later chapter. You will find two kinds of chapters in this book: concept chapters and project chapters. In concept chapters, you learn about an aspect of Rust. In project chapter, actually, I think I probably should start a Rust book projects. I think I probably should start a new Rust book project repository. Anyway, where are we? In the concept project chapter. In concept chapters, you will learn about an aspect of Rust. In project chapters, we will build a small program together, applying what you've learned so far. Chapter 2, 12, 20 are project chapters.
The rest are concept chapters. Okay. Chapter 1 explains how to install Rust, how to write Hello World program, and how to use Cargill, Rust package manager, and build tool. Chapter 2 is a hand-on introduction to writing a program in Rust, having you build up a number of guessing game. Here we will cover concepts at a high level, and later chapters will provide additional detail. If you want to get your hands dirty right away, Chapter 2 is the place for that. Chapter 3 covers Rust features that are similar to those of other programming languages, and in Chapter 4 you will learn about Rust ownership system. If you're a particularly meticulous learner who prefers to learn every detail before moving to the next, you might want to skip Chapter 2, okay, and go straight to Chapter 3, and return to Chapter 2 when you like to work on a project applying the details you've learned. Chapter 5 discusses structs and methods. Chapter 6 covers enums, match expressions, and the if-let control flow structure. You will use structs and enums to make custom types in Rust. Okay. In Chapter 7, I think I really just don't know what is the correct way of learning a programming language. I guess it just doesn't work for Rust because it's like such a different paradigm from like most other languages. So when I was learning Python, right, I was just like making a project in Python, and it didn't took me too long because like there aren't that many new concepts. But I feel like with Rust, there is a shitload of concepts. But since I have done something in Rust, it feels like I kind of know what these are, but at the same time, I also don't really know what these are. So I think I'm in a very awkward spot when it comes to learning Rust. But I guess and I guess that's why I'm like maybe recording this as I'm going through it, because I just don't think I can go through it myself. It's so hard. Or at least I feel like it would be more tedious, right? Because I'm recording this, I feel like at least I have certain level of social interaction, even though it's not real. And just imagine someone listening to this. Probably no one's listening, but whatever. In Chapter 7, you will learn about Rust module system and about private rules for organizing your codes and its public application programming interface. Okay. Chapter 8 discusses some common collections data structures that the standard library provides, such as vectors, strings, and hash maps. Chapter 9 explores Rust error handling philosophy and techniques. Chapter 10 digs into generics, traits, and lifetime, which give you the power to define code that applies to multiple types. Okay, how's lifetime supposed to do that? I actually have no idea what lifetime is. I know that I know there's like a fucking single like parenthesis and an static. I know like that's something that a lot of people are using, but I have no idea what lifetime is. Which gives you power to define code that applies to multiple types. Chapter 11 is all about testing, which even with Rust safety guarantees is necessary to ensure your program's logic is correct. Yeah, obviously. Chapter 12, we will build our own implementation of a subset of functions from the grep command. Okay, that's interesting. Command line tool that searches for text within files. For this, we will use many of the concepts that we discussed in the previous chapters. Okay, so they're going to talk about generics, lifetime, and I'm kind of excited. I'm kind of hyped. Chapter 13 explores closures and iterators. Okay, that's interesting. Features of Rust that come from functional programming languages. In chapter 14, we will examine cargo in more depth and talk about the best practices for sharing your libraries with others. Chapter 15 discusses smart pointer. Okay, smart pointers that the standard library provides and the traits that enables their functionality. In chapter 16, we'll walk through different models of concurrent programming and talk about how Rust helps you to program in multiple threads fearlessly. Okay. Chapter 17 looks at how Rust idioms compare to object-oriented programming principles that you might. Chapter 17 looks at how Rust idioms compare to object-oriented programming principles you might be familiar with. Chapter 18 is a reference on patterns and pattern matching, which are powerful ways of expressing ideas throughout Rust programs. Chapter 19 contains a smorgasbord. How do you say that? Smorgasbord means a smorgasbord of advanced topics of interest, including unsafe Rust, macros, and more about lifetimes, traits, types, functions, and closures. In chapter 20, we will complete a project in which we will implement a low-level multi-threaded web server. Wow, that's exciting. Finally, some appendix contain useful information about the language in a more reference-like format. Okay. Appendix A covers Rust keywords. Appendix B covers Rust operators and symbols. Appendix C covers the derivable traits provided by the standard library. Appendix D covers some useful development tools. Appendix E contains Rust edition. What is Rust? Explains Rust editions. In Appendix F, you can find translations of the book. What? I thought that's something that you should put at the beginning, right? I don't know. In the Appendix G, we will cover how Rust is made and what nightly Rust is. Okay, nightly Rust. There is no wrong way to read this book. If you want to skip ahead, go for it. You might have to jump back to earlier chapters if you experience any confusion, but do whatever works for you. An important part of the process of learning Rust is learning how to read the error messages. An important part of the process of learning Rust is learning how to read the error messages the compiler displays. This will guide you towards working code. As such, we will provide many examples that don't compile along with the error message that the compiler will show you in each situation. Know that if you enter and run a random example, it may not compile. Make sure you read the surrounding text to see whether the example you're trying to run
is meant to error. Ferris will also help. Ferris, is that the mascot? Is that the mascot of? Yeah, I think that's the mascot for Rust. Ferris will also help you to distinguish the code that isn't meant to work. This code does not compile. This code panics. This code does not produce the desired behavior, okay? In most situations, we will let you to the correct version of any code that doesn't compile. Source code. Source code is compiled from this GitHub repository. Getting started. We have already done that. Installation. I think Actually, I don't know if I've. What is the command for a new project? Cargo init? Is that? Oh yeah, it is. Cargo init. Yeah, cargo init. We're not gonna. There's a cargo. Rust up. Rust up. Is that? Yep, it's Rust up. Hello world! Now that you've installed Rust, it's time to write your first program, a Rust program. It's traditional in order to write a hello world, so we will do it here. Okay, we're gonna write in okay, this is main.rs. I think they have already created for us. Oh, we can compile a single file. Okay, so Rust C, this file gives us this. Regardless of your operating system, the string hello world should print to the terminal. If you don't see the output, refers to the troubleshooting part of the installation. Okay. Hello world did print. Congratulations. You've officially written a Rust program. This makes you a Rust programmer. Welcome. Anatomy. It's anatomy. Anatomy, a branch of science concerned with bodily structure of humans, animals, and other living organisms, especially by review. Whatever. Anatomy of a Rust program. Reveal the hello world in detail. Okay. And this one is like pretty standard. I already know that. It's a Rust macro. Compile running your separate steps. You've just run a newly created program, so let's examine each step in the process. Before running the Rust program, you must compile it using the Rust compiler by entering the Rust-C command and passing it the name to your source file, like this. If you have C and C++ background, you may notice it's similar to GCC and CLang. After compiling successfully, Rust outputs the binary executable. On Linux, macOS, and PowerShell and Windows, you can see the executable by entering the ls command. Linux, macOS, you will see two files. With PowerShell and Windows, you will see the same file you will see using CMD. With CMD on Windows, you will enter the following. that CMD sucks. This shows the source code file with the RES extension and the executable file man.exe on Windows, but man on all other platforms. And when using Windows, a file containing debugging information with the dpdb extension. From there, you can run the man like this, okay. Yeah, I mean, shouldn't be the most surprising thing. So main. Question 2, okay. The following program, we will run it. Okay. Say when you run the command this. Rust-C hello res from the command line, which statement best describes what happens next? Going to run? No, it's going to compile. Yeah, I got both of them correct. Hello cargo, okay, cargo, let's go. Cargo is Rust's build system and package manager. Most Rustations? Crustaceans? I thought it was crustacean, but apparently it's Rustations. Anyway, use this tool to manage their Rust project because Cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries. We call the libraries that your code needs dependencies. This snippet of Rust program, like the simplest Rust program, like the one we've written so far, don't have any dependencies. If we had built the Hello World project with Cargo, it would only use the part of Cargo that handles building your code. As you write more complex Rust programs, you will add dependencies, and if you start the project using Cargo, adding dependencies will be much easier to do. Because the vast majority of Rust projects use Cargo, the rest of the book assumes that you are using Cargo too. Cargo comes installed with Rust if you use the official installer discussed in the installation section. If you install Rust through some other means, check whether Cargo is installed by entering the following in the command in your terminal. Cargo version. If you see a version number, you have it. If you see an error, such as command not found, look at the documentation for your method of installation. Yeah, I mean, Cargo new. What? I thought it's Cargo init, but what's the difference between Cargo init and Cargo new then? I always just use Cargo init, but it actually makes me curious. Init creates packaging names. Okay, so init is the correct one. What? So I can run Cargo new in both places. Interesting. Open cargo.toml. See something like this. Yeah. I'm not sure if, like, a lot of people likes Toml, but I'm not a big fan of Toml, because, like, I just don't like languages that gives you Like I don't like configuration languages that gives you many ways of expressing the same thing. I think like a configuration should be easy to read, and like it should gives you one and only one method of configuring your code. But I digress. The first line package is a selection handling that indicates that the following statements are configuring the package. We are adding more information to this file. We will add another selection. Okay. As we add more information to this file, we will add another selection. The next 3 lines are, I think I already know this, I don't really need any. Oh, let's generate a hello world program for you. Wait, what? Oh yeah. Build and run the cargo project, and just cargo build. Cargo run. It's more convenient and have to remember cargo and yeah, it's cargo checks. It's a command that quickly checks if your code compiles. Okay. Why would you not want an executable? Often cargo check is much faster than cargo build because it skips the steps of producing an executable. If you are continually checking your work while running the code, cargo check will speed up the process of letting you know if the project is still compiling. As such, many rustations run cargo check periodically as they write their program to make sure it compiles. Then they will run cargo run when they are ready to use the executable. Let's recap what we learned so far, okay? Use for releases. Yeah. Cargo as convention. The simplest project, cargo doesn't provide a lot of value over just Rust C, but it will provide its width as your programs become more intricate. Once programs grow to multiple files or need a dependency, it's much easier to let cargo coordinate the build. Even though the Hello Cargo project is simple, it now uses much of the real tooling you will use in the rest of your Rust career. In fact, to work with any existing project, you can use the following command to check out the code using git. In fact, for any to work with any existing project, you can use the following command to check out the code using git, change to project directory, and build. Quiz. Say you just download a cargo project, then you run cargo run in the command line. Which statement is not true about what happens next? It's going to build, it's going to execute, it doesn't watch. Summary. You're ready off to a great start on your Rust journey in this chapter. You've learned how to install whatever. I think I don't need to read that. Okay, the project chapter. Programming a guessing game. Let's jump into Rust by working through a hands-on project together. This chapter introduces you to a few common Rust concepts by showing you how to use them in real program. How long is this video? Oh my god, it's already been an hour. That's why I'm so sleepy. I mean, I was sleepy even before this, but like, oh man, I feel like I'm like actually sleepy now. Oof, that's a lot to read. That's pretty long. That is pretty fucking long. Are we doing this today? Probably not. How about tomorrow? Yeah, we can do this tomorrow together. Or maybe just like a few hours later, but not now. Like if it's a bit too much for me. Anyway, that's pretty much all for this video. I don't know why you're still watching this, but good for you. And hope to see you in the next one.